Hi everyone, today I'm going to discuss with you data preparations for data mining and machine learning knowledge discoveries. One of the preparations that we have to do is data cleaning. Before we apply the data to any machine learning algorithms or models, then we should better understand the data characteristics. The visualization is a good tool for us to understand the data. As you may see, in general computers, more specifically data mining and machine learning, can take data and to return something that that module processed. So if garbage comes in, then output, although the algorithms is very strong and useful, when garbage comes in, then garbage goes out. So data is very, very important. The data that we may have, not necessarily in a formal formats. So we have to make sure data that we have is really in good format that the algorithm or models, data mining model or machine learning models would expect. So processes of data preparations shown on this slide, 4 components: exploratory data analysis, data wrangling, data visualization, and data splitting. So EDA, for example, is to explore and analyze data sets to discover patterns and spot anomalies. Of course, there are some anomalies, and better understand the data that we are working with. And another process is the data wrangling, which is to clean and transform raw data into another format that our data mining tool prefers to. Data visualization is graphical representation of data. So it could be a chart or a graph or something in combinations. So that's help us understand the data quickly and better. Finally, but not the least, data splitting. Not all data, although cleaned, are going to come into our data mining and or machine learning process, but we have to split it. So part of the data, or majority of the data, will be used for training, and small portion maybe for testing and validating. Therefore, the model that we would want to construct may be able to represent the real world data itself. So lots of the tools and techniques available. Today we're going to work on, I wanted to do all theories and slides that I posted on Blackboard on your own, and get back here. For the Google Colab. The one that we are going to work on is handling missing data. There is not all data, as I said, are well cleaned, so we have to make sure our data is good enough. And then data imputations, renaming columns, mutating column types, and data cleaning reviews, things like that. The goal of this lab is to help you be comfortable using Pandas. So Panda is a package that you may want to use. So if you want to see some of the Pandas, then you can click this. It goes to, I'll post something that you may like. Python basic, that is also. So forget about this. Okay, first of all, I wanted to run this. So we need to import the Panda let's call it PD, and numpy, just in case if you want to do statistical process. And then here is a URL, and it has CSV files, so we can bring it down. So by having that, if you want to see what is a movie DF, then it gives us some of those. Okay, this is kind of a movies, right? And see, there is this title, year, airtime, genre, and ranking, and overview, director, stars, movie stars, 4 of the movie stars, number of votes. And then gross. Okay. So if you have the CSV data, then you can read the CSVs using Pandas, and you can get that. So Panda, because we have a Panda, so we want to use some of those. This is a data frame. That is one of the constructor available in Pandas. So we can edit the data itself, and then we can see the head files of those. Having those, how many the rows? We have 1, 2, 3, 4, 5, 6 rows, right? 2, 3, 4, 5, 6 rows. How many columns? 1, 2, 3, 4, 5 columns. So we have name, age, height, team, favorite color, 5 columns, and then rows, as many rows as we could, right? If we want to see first 5 rows, then you can use this df.head. Head is a function that is available in df. df is data frame. Okay, so if you click this, then you can see convert this data frame in interactive table. This is for chart, if you want to see some. So let's click this. Then this is something that we could have more interactive. So we can do filter. Currently there is a CSV format, but you can make it a JSON format. This is a JSON formats. Yeah. And if you want to see some of the visualization, then you can see it like this. Categorical distributions, 2-dimensional distributions, and time series. Some of the values that you can see. 2-dimensional categorical distributions. Some of the values here are categoricals. These are the categoricals. This is more numerical data. Age and height numerical data, and all others are categorical data, so that we can see those. Okay. So once you read the data using Panda in the form of data frame, then you can use it. You can visualize it. You can see the data clearly. So that, for example, here the team, so not available data. This is kind of a missing data, right? Here we have a missing data as well. So that type of things can be figured out very easily. Okay. So here together, let's find the non-null count to determine if there is any missing data. How can you get that? Remember that this data is labeled by df, right? This is a df. We call it df. So we use some functions available in df. So df dot. And if you do info, that is the function, and hit it, then you can see the range of index 6 entries 0 to 5, so total 6. Data columns, 5 columns. So we have those 5 columns. And non-null, names are all non-null, 6 non-nulls. But age, 5 non-null, which means all, how many numbers? We have 6 rows available, but only 5 of those are non-null. Same thing here. Team, only 4 are non-null, which means 2 teams, 2 rows for the team is missing, right? That's what it is. So as it says here, if you use isNull, then df dot isNull, that function, then it gives us which one. If it says false, then isNull. No, what that means is not missing, right? If it says false, then first row is good data. Second row of the data, there's some issue on team attributes. And then third rows are good because they are all false, and so on and so forth, right? So if you want to drop rows, show embeds data, since it is missing. So what is the show embeds? So if you go back, show embeds, lots of missing, right? So age is missing, height is missing, team is missing. So why should we keep it? So if we want to drop that row, we can drop it in this data frame. So we can say df.drop, and then we need to indicate by index. Index equals the 4th rows, well actually 5th rows, because it counts from 0. So 5th rows, then it'll be dropped, and then we can do df info, see if it is dropped that way. It is dropped, but why is not? Yeah, if we were only this, then it is dropped, right? As opposed to the original here, then we have, let's say, df. This guy has the 4th rows. Joel has 3 columns missing, but we dropped that here. So for the index number 4, which is 5th rows, dropped out. We can do a little further. If we want to drop a particular attributes, then you can do that. Here, df underscore dropped equal df dot drop na, and then subset of the attributes. If you want to drop age only, then age in the list, that is, it is dropped, right? So if you want to see df dropped, then what age is here? What is dropped? df. Is it dropped? Remove any missing values. Remove any missing values of. Okay. So if we do df dropped, ages, yeah, remove any values. Currently, for example, originally here the age is missing the fourth rows, not fifth rows. You will. That's yeah, that row removed. Oh, here. Remove favorite color features. Then you can do df.drop and column. Columns equals color. So here favorite color entire, the favorite column, this column is dropped. So we can drop entire columns. If you want to drop the rows, if there is a missing data for this particular attributes, then you can use this drop NA. Here we do drop and columns. Okay, part 2, data imputations. As it says here, if you run this once more, so name, age, GPA, and year. So this is like university data. Some data is missing. So Raj's age is missing, as you see here. If you see Raji 1, 2, 3, 4, 5, 6. This is Raji, right? 6th. This is Raji. So Raji's age is missing right now. If you see here, how do you know that is missing? Then you can see, first of all, so students df.info. Then you can see age, there is one data missing, and year, no, GPA, 2 data missing, and name and year, okay, right? So in this case, if you want to replace that age, because that is missing, the reasonable way that you can do for imputation, I would say, what about the average of the ages, right? If that is university data, student data, then if there is any age missing, then more likely they are near homogeneous. So if we apply the missing data by computing the average, then the age for Raji will be closer, right? At least it's not really abnormal data, even if we make the average data and apply it to Raji's missing data points, then it may be reasonable. So that is the rationales. Then how can we make it? Where is it? Yeah, right here. Let's use the means of non-missing values in the column age to replace the missing value with the means. So we have to first get the mean values. Mean age. So mean age can be obtained from student df, and we say age. So that, let's make it step by step. So what is this? Student df age. Then it gives us the age itself, right? This is the age. So if we want to make an average, which is mean value, then we can get the mean value. This is the mean value of their average. So let's call this mean age. And then we can replace the mean values to the data points of the missing. So student df and ag, okay, equals students df ag, and fill that attributes, non-value attributes, na, fill na, if value with the value of mean ag. Then it can be replaced, and if you want to see the data, if to check whether it is right, here Raj's data is now 22,833, which is that we obtained, right here. So homework is I want to do the GPAs, median values of the GPAs, and then replace it. Renaming columns. If you want to rename, sometimes you want to do that, right? Because data rename GPA to, this is a lowercase GPA but uppercase GPA. So how can you make it? Then back to the student df file again. So it's student underscore df dot rename, and then columns. The cheating sheets will be posted, so you'll get that. And then small GPA will be replaced with uppercase GPA. Okay, and then if we want to see if it is renamed, then you can see here GPA, right? That is renamed. Homework number 2, similarly rename the rest of the columns of all column names begins with capital letters. You can do it. And mutating column types. Let's change the data types of AG and GPA columns to floating points rather than the integer. Then students df equals student underscore df dot as type, use as type function. There the AG float and GPA, that is also float. Interestingly, remember here, this function takes what about the modifications in the dictionary formats. So this is the key and this is the value. If there is an AG, then type should be float. If there is a GPA, then type is a float. That's what it is. I think it is because of AG. AG is not originally, so far AG is a small case, right? So we need to put here a lowercase of GPA. So it'll be okay. Dropping any duplicate. The reviews, as you see here, we already run that, right? So if you want to do, for example, remove a duplicate using drop duplicates functions, you can do drop underscore duplication functions. I'll make this in the next line. Here, remove duplicates using drop duplicates. And then we can say in place and equal true, so that it can be movie. Let's go to drop duplicates. So we do duplicates. So what is the duplicates right now here? So how many? Oh, this is code. Oh, there are 1,000 entries. It's almost impossible to take a look at that. So there's a duplicate that can be replaced. So if we do this, after do this, then we can see the difference. So before we duplicate rows removed, and after removed, we can see still is, we cannot see that here, right? Movie def info, we cannot see it clearly. Is it possible? Let me try to see if that is possible. It's not possible. Maybe there is no duplicates. I'm not sure. And another one here. Let's drop the following columns: stars 3 and stars 4. That we did that already, right? How we can drop that? So we can do here drop, and then star 3. Star 4, axis, and that is dropped. It's already dropped. That may be the reason. Okay, so what we will do, we can do code, take that out, and we'll do here. Yeah. So I dropped it here once, and then I said redo. That is reason it. So star 1 and star 2, 3 and 4 are dropped. And there's a homeworks. Yeah, this is it. I want to make a comments. Those who are having difficulties making homework. I know some of you guys simply file this and download it PY format. There are two problems. If you do this PY file, it is not pure Python files. It is lots of lines not understood by Python. Of course, there is an error, right? And another problem is if you convert this entire, then they are not all homeworks. I do not want you to submit, for example, any exercises that we have here. I don't want to grade this, right? This is not the homework assignments. So do not submit by clicking simply one button. I do not want, what is the credit if you do it that way, right? As I said, you should submit. The best way is that, for example, if you have a Python user, then bring the Python and new editor here, then you can copy, for example, the code itself, right? So simply an example. Then you can say here problem 1.2, if that is a homework, and then you can say that is it. And then problem 5.2, and you copy and paste some of the code that you exercises here, right? So this is the Google Colab, which means I wanted to exercise and practice here in Google Colab. And your homework submission should be the real, the Python files as I ask you to do, okay? Yeah. Otherwise, it cannot be evaluated. All right, good luck. I'll see you next week.